Electricity is important for our society. Lights our cities, powers our industry, and we need it for our communication and information technology. In the age of climate change, our power systems need to become more sustainable. And at the same time, they also need to become more efficient. And that's not easy to solve.
Sustainability is a big topic for Siemens itself. Everybody at Siemens knows sustainability. It's needed to save our world. We have so many problems around the world, and if we neglect some problems, for example, climate, then we can leave our children a better world. That's what I'm working for. I want to have that foresight that my children will have also a nice life, not only me. That's what drives me.
The global warming potential of SF6 is over 20,000. That means 1 kilogram of SF6 has the same impact to our environment and global heating like 20 tons of CO2. And that's important for the environment and our society.
When we look at SF6, it is often used in switchgears because it has very good dielectric properties and thermal properties. But it has a flip side. SF6 has a negative impact on the environment because it has a high global warming potential. That means it will contribute to the greenhouse effect. And this is why, in the end, the European Union forces with this regulation to switch the gas.
There was no further solution. We needed to switch, and we needed to find a solution for our future. If there's no SF6 switchgear, the factory will be closed. We had to do something, and we found the solution.
Switchgears like this are the junction points of our power grid, and therefore they belong to our power infrastructure.
Switchgears with SF6 are very safe, but over a large lifetime, accidents or leakage can happen. So the Blue GIS technology only uses natural gases, which are part of the environment air. So we have no impact in case of accidents to our environment.
For some applications in energy business, also fluorinated substances are still used as a replacement for SF6. They fulfill the requirements, but they are not that sustainable.
The new gas in the blue products is based on a mixture of natural occurring gases and is more sustainable. We use a gas with a low global warming potential, and it's not toxic. Therefore, it's a good solution for the environment. SF6 is the best technical solution that you can use in a switchgear. You have small distances and can realize small products. Critical is to emit SF6 in an environmental, and that is why we eliminate SF6 from the whole supply chain.
Instead of SF6, in our Blue GIS, we use natural origin gases that are oxygen, nitrogen, and CO2. And if there is no SF6 in the switchgear, there is also no risk that some of it can be released to the atmosphere.
We didn't develop this gas. It's a surrounding gas. It's a part of surrounding gas, so nearly perfect for us, but maybe a challenge for others.
It has been decided by the European Union to ban F-gases because F-gas-free technologies have reached application maturity, because we are working on it since a couple of years, and now the time is right.
The shifts to the alternative gases are very crucial for the environment and sustainability. There are also technical challenges. We have to understand it and address it to be ahead and succeed.
With simulation, we can make physics visible. We can look in our products and we can see what has happened. We combine physics and we can help our designers.
SF6 is a good gas for heat dissipation, because it's heavy and dense, and that's not the case for natural origin gases. And if you want to do it with natural origin gases, we have to take care about heat dissipation. We need to find other solutions. And the development of these solutions are supported by the simulation of Damian's multi-physics thermal simulation.
Hi, I'm Damien Barron, and I'm a simulation engineer, and I'm a member of the R&D team in the GIS. I am doing multi-physics simulations who support our design teams. They are simulations where you can combine several physics, and I am doing also innovation projects. From the temperature rise point of view, SF6 had very good thermal properties regarding the flow, and our new gases, they have not such a good properties. So to compensate this fact, we have to optimize our design. That means current path and housing, and to add more heat transfer possibilities. When we faced this challenge, the temperature rise simulation really helped us, because with this multi-physics simulation, we could analyze on one hand the magnetic field and reduce the heat source, and on the other hand, we could optimize the flow, work with heat sinks, and optimize the design.
My name is Uğur Yasavur. I am a simulation expert for structural analysis, and we played a crucial role in development. We reduced the need for a lot of testing by evaluating design variants virtually before testing. And it helps us to be on time and cut the R&D cost.
My name is Markus Resch. I'm working for Siemens. I'm a team manager in R&D in Frankfurt, and I work for the technology innovation team and my team called computational simulation. Simulations are digital twins. Simulations are digital prototypes, and with these prototypes you can play, you can change the boundary conditions and use it before you realize a product. Innovation is our job. The blue GIS story is just at the beginning, but I think it's the first step into the future.
My name is Christian Korolonek. I'm a simulation expert at Siemens. My main topic is structural simulation. For me, the most challenging part was to find good solutions together with our designers for the vessel design. Because of the higher pressure, it wasn't easy to find a good stiffener solution. Thanks to the simulation, we were able to compare a lot of digital prototypes to find the best solution.
My name is Achim Kalter. I'm Head of Technology and Innovations for Siemens medium voltage gas insulated switchgear. Most challenging was gas insulation with natural origin gases that have 3 times worse dielectric strengths compared to SF6. What helps us here is the simulation that gives us a better prediction about discharge location. In conventional simulation tools that we used earlier, the electric field strength is displayed and the strongest point of the electric field. With the new simulation tool Sven is using, we are able now to predict the location of the most likely electrical discharge, of the point where the gas breakthrough will happen. Particularly for voltage levels beyond 24 kilovolts, dielectric simulation becomes more and more difficult with natural origin gases. Our new tool, the gas discharge tool, enables us to improvement to dielectric strength with much less development cycles and less hardware tests.
My name is Sven Ettingshausen. I'm a simulation expert in the R&D of gas-insulated switchgears in Frankfurt, and I'm doing electrostatic simulations since 16 years now. The new gas is extremely difficult for electrical fields, so we have many experts at Siemens knowing very well how to deal with these new surrounding gases. So the experts giving their knowledge to the new colleagues, to the older colleagues, and we collaborate. And so we can avoid starter mistakes, concentrate on the real topics of our switchgears. So we have experience, for example, in our team for several years. Before I started, there were electrostatic simulations, so let's say 25 years experience in this direction. And all this knowledge helps us finding the solution right now.
At the beginning, I wasn't sure what a simulation can contribute to sustainability, but then after a while I recognized that it can reduce the tests, it can accelerate the development time, and of course improve the quality of the product. The multi-physics simulation approach connects several physical phenomena, and this is a big advantage because in reality you can't observe physics in a single way. You have to see the connections, and this is a very complex simulation, and in this case we connect the magnetic field with the flow, and in the end you have this dependency of these 2 physical phenomena, which helps to analyze the whole picture.
The challenge was not only to find the optimum design from the structural point of view, because the switchgear also has to stay the voltage and to carry a very high current without overheating. It was solved by a lot of iterations and interactions between the different experts from the different types of physics. It was very important for us to create virtual prototypes for a better understanding of the physics, to discuss these topics with our team members.
There are a lot of challenges like thermal, mechanical and electrical. I can say it from mechanical perspective. We had to handle higher pressure by increasing stiffness of the design, and we achieved it successfully through collaboration with our R&D colleagues. When I talked to my family and my wife about my work and that I am working on a sustainable product like a GIS, and they were very proud of me and that I'm working on a product to make our future better and greener.
One person can solve the whole development of a switchgear. So it's teamwork. It's always teamwork. I'm extremely proud of being part of the simulation team, but also I'm proud of being part of the R&D in Frankfurt, of being part in collaboration with my colleagues in India, in China, of course USA, Czech Republic. So I'm a small individual in a very big world. So that's what's being extremely exciting.
Simulation is not a big major breakthrough. We use it day by day, and it's an iteration process in the R&D, and it is established, and therefore it's more a daily business. From simulation perspective, the first point was to support the decisions with simulations, and the second, to have the right tools and the capacity to support the R&D teams.
The simulation team works closely together with our product development colleagues, with the testing department, and with other interface partners that make BlueGIS a reality. I would like to see BlueGIS successful not only in Europe, where the F-gas regulation applies, but also in other countries that decide to ban SF6 and to make energy grids more sustainable.
We are the R&D department. That's our business. That's a big challenge. And for every challenge we find a solution.